for the supply chain ontology. So what are the challenges in developing a unified model for supply chain ontology? And how, let's say, to this unified model, how could we establish its relation of this ontology of supply chain to manufacturing operations, if you can say a few words about that?
Yeah, I mean, one challenge is that we have a lot of stakeholders involved and they have their own viewpoints and perspective, right? So to have a unified ontology that addresses varying perspectives, that's always a challenge. And well, we hope that using a top-level ontology will solve the problem, but at some from one aspect, like forcing a single viewpoint through a top-level ontology might become problematic. But it will give us some rules, some structure, some way of thinking and modeling. So we hope that using top-level ontology will address some part of the challenge. And then the second part of your question was relating it to manufacturing operations. Yes, we have internal supply chain and external supply chain. When we go to internal supply chain, we talk about the internal manufacturing operations of a company. And so basically, they are the same entities, they are processes, but within different boundaries. So we try to model processes no matter where, if they are inside a manufacturing organization or outside, and then try to link them appropriately.
Good, thank you. So now I think we can go a little bit to the discussion of the whole session. So there was a comment in the question and answers about what you said, Farad, from Emmanuel, I think, yes, about ontologies as primary machine-oriented tools. And the thing is that how we can consider ontologies also as a kind of enabler or a kind of tool that can enhance interoperability between people as well. So yeah, so this is, I don't know if you see the question. What do you think about that? So, and now also it is highlighted that this is a topic of Industry 5.0, where human is at the center of the operations activities, industrial and other activities. So I understand from Emmanuel's point that we need technologies to enable interoperability between people. So what do you think? So can ontologies play this role, or should remain, let's say, as tools to enable interoperability between machines? And machines, I mean software that are serving machines.
Can I have it on that? Or?
Yes, please, of course.
Yeah, okay, sure, yeah. So, yeah, in fact, yeah, exactly. That's really something we need. A human in the loop is required. The problem with some of the ontologies that we have seen is that they are mainly designed for human, ignoring machines. So we say, okay, now we should have human and machine together. That's why in our definitions, we'd like to have human-friendly natural language definitions. We would like to involve human experts, such that, first of all, humans are the main users of the ontology. So the definitions should make sense for them first before we can formalize them. So I totally agree with Emmanuel, and yeah, human role is very critical here.
And then another question, which is, I think, related to that, is as we see also in system engineering, in standards and the discussion that we have. So we have different viewpoints, and particularly also in the domain supply chain, but also in maintenance. So where I have some experience, we have various different viewpoints, and we need to integrate them. How this could be, let's say, addressed in a domain reference ontology for maintenance, for example. So I mean the need to integrate different viewpoints, and as we discussed in the previously, so this situation that people define terms in different words or in having something different in mind.
Okay,
Can you
so
take?
sorry.
Maybe Melinda, you can start.
Okay, so I think this leads to a huge amount of confusion. Often people define things differently, but it's in fact a part of their background or training, and this creates enormous confusion. And one of the great opportunities, particularly in something like failure modes and effects analysis, is to move away from people's loose use of terms when they describe things. And by taking a richer set of terms around that, we can nail into the concept they actually mean and map it to the physics. And to take the words that people use to describe something, like, I can't turn this and it's stuck, all map to a concept of fail to open, which is an ISO 14224 standard. So the challenge for us is to actually add clarity and conciseness by using reasoning to remove the ambiguity caused by the language used by different people. So I think this is a huge opportunity, and we're working in this area. We have a limited number of failure codes that really are discrete. They're broadly orthogonal to each other. But if you look at the failure mode codes that companies use, there are like 80 of the things, and most of them are duplicates and not clearly just differentiated. And so people do a lot of work with those failure codes. They spend enormous amounts of money doing Pareto tables and tracking things, but most of them are wrong. So getting those right and clearly differentiated, regardless of the background or semantics of the people used, is a huge opportunity for ontologies.
And I think how we can do it.
We are working on that.
So this be realized. So
yeah. So part of this is
yeah, I know.
Go on.
But it's yeah. What I was thinking is that in order to implement an ontology or to design an ontology, I don't know what is the correct term here. We have to pass through a process of defining terms through a natural language definition between experts, subject matter experts as SMEs, that not small and medium enterprises, subject matter experts, and knowledge engineers or ontologists. This process takes time, but I understand that it is crucial before we go to the formal definitions using FOL or CL or OWL or whatever. I think that this process, this phase of ontology development, this dialogue between people to agree on a proper definition in natural language is very important. And I think this is a step that helps the interoperability between people as well. So
yeah, so Dimitri, all I would say is that we've been doing this for 3 years in the iOS, and as far as I can concern, we just go round in circles. So at some stage, we have to move away from coalescing everything on a simple term, and everybody new comes with a different definition, and we have to take into account both the class and its relationships to define a concept. And that is, just defining the term by itself is not enough. You have to define the concept and the relations around it, and we should spend more time doing that.
Very good. Then there was also in first comment by Eve, and then I asked somehow also about the system engineering ontology, which could be a formal ontology. By formal ontology, I understand that it should be a middle-level ontology used by other ontologies also. And in my understanding, so here we have the examples of a maintenance ontology and of a supply chain ontology. And in my understanding, these, let's say, tools, these models are applicable to particular or phases of the life cycle of a product. So my question is how, let's say, a system engineering ontology, which is defined here in the talk in the title as a foundational ontology, what is the role of such a system engineering ontology is to be in a kind of upper level of domain ontologies and help to link applications and models used in various phases of the life cycle. Is that something that we consider, Genji?
Uh, yeah, I think first thing from the systems engineering domain, actually, it in systems engineering domain, systems engineering or system thinking is an approach for the engineers how to consider, how to see the world. So that's why when we use systems engineering or system thinking, we use such framework or such approach to formalize the real world. So that's why I think it may, maybe if it depends on how we treat the systems engineering ontology. I think maybe we can put them in the middle uh, in the domain of some type of high level ontology. But this is not from the ontology engineering. This is from the systems engineering way because we have different approach to see the world. So yeah. But actually the nature of the world actually they are the same. So yeah.
And also in your talk, you also talked about model-based system engineering ontology. What is the difference between a system engineering ontology and the model-based system engineering ontology?
Yeah, so that's why just as I introduced, I take one example is that, for example, there's one company who want to develop a one pencil, and they have their own CAT tool. For example, they have their CAT tool. They use the CAT tool to develop the model for the pencil. So sometimes, so for the people in the company, they always think, okay, the pencil and the model of the pencil, they are the same. But in fact, actually, they are different. So model-based systems engineering ontology is used to represent the model. I mean, which represent the system. So which represent the physical world. And what we want to say is that the model and the real world, and I mean the real world and their model actually they are totally different things. So that's why I want to say the model-based systems engineering is ontology is some type of ontology to represent the architecture model, the graphical model of this system and the systems engineering perspective.
So the technicalities of the model, let's say, using, let's say, nodes, links, relations, etc. This is what you mean.
Yes.
And to automatize something, somehow this works. Very good, thank you. So we have an interesting question from Peter Klein now, who brings into the discussion the topic or the concept of which is popular, so emerging concept of digital twins in manufacturing. And also you see the I think I don't know if you've seen all your screen, and how it is related with edge computing and or cloud computing, and how digital twins are, let's say, linked to domain ontologies. For example, we may have a digital twin for a supply chain solution or a digital twin for maintenance. So there is a lot of also in the market, let's say, products or solutions claiming to sell digital twins for predictive maintenance, for example. So, and this question is for all the presenters. So let's take first Melinda with this digital twin for predictive maintenance. What do you think? So how Ontology can support the digital twin for predictive maintenance?
Don't get me started. Yeah, my God, it's a mechanism for consultants to earn vast amounts of money. So, you know, I replied to Peter in the chat. I interpreted his question in a slightly different way. I mean, I think the digital twin itself needs maintenance. You know, if you have a model and you have a physical thing. They both need maintenance. So you just use the maintenance domain ontology to manage
Autologists need maintenance as well, Melita.
That's right. That's right. So I think we've had digital twins forever. Process plants have had simulations for forever. I have yet to see any really substantially good examples of predictive maintenance digital twins that really work in the way that I think they should. So I'm not worried about that at the moment. Give me a working predictive maintenance digital twin that's used by an industry partner as part of maintenance management and tied into their work order system, and I'll pay attention. But until I see one, and I haven't yet, I'm not worried about it.
Mm-hmm. Farhad, what do you see in the supply chain, let's say, market or communities? Is there a discussion using digital twins or applications of digital twins there?
Yeah, so there are some emerging models of like digital twins for supply chains, but they are not being used very extensively yet, to the best of my knowledge. But well, it's all about how you model data that is actually coming from digital twins. So it's not, in terms of ontology, it is not really adding a new challenge to this whole problem statement we have. We still have a set of data that needs to be represented using or aligned with that ontology. So a digital twin for a supply chain will have, for example, some timestamps. So how to model time or temporal regions is the same problem. So it doesn't really impose new sets of problems. It's just kind of larger in a scale, because a digital twin should be a comprehensive model of a supply chain, and that's why we are working with larger scale data, very diverse data, but the type of ontological modeling challenges are not necessarily different, because at the end of the day, we are still dealing with data. So that's my take.
Mm-hmm. Good. Thank you. And Jinji, I will come to you with the next, let's say, part of answer to this question. So digital twins are, as you, I think so, in your one of the first slides, or if you take the life cycle, design, production, maintenance, so use and maintenance, and then end of life, we may imagine that we have various digital twins that are implemented to serve, to provide services in the various topics of in each phase of the life cycle. So how about a system engineering ontology or a model-based system engineering approach?
Mm-hmm.
Would it be useful to link these digital twins together, or harmonize their operations, or optimize their operations? Or we let's say allow people to use them independently, and then somehow they need to coordinate?
Okay, thank you for this question. Interesting question. Actually, in systems engineering, digital twin, the guy related to digital twin, they have a lot of people, they are focusing on how to use simulation model, simulation tool, and maybe create the digital twin to support some real domain, to solve real domain specific problems. And some people, they are focusing on develop some framework for digital twins, because just as we discussed, the digital twin, we already have, for the whole life cycle, we already have different computer-based models or mathematical models, and this model already exist. They already exist in the work. So this is not new thing, but why they propose this new concept about digital twin? I think they are focusing on how to use the model to solve the real domain problem. They may trying to make this framework, digital twins framework, or this approach to solve the real problem in the work. So that's why they have different frameworks. I think the systems engineering ontology in this case is we can support, as we introduced in the presentation, we can support to describe the interrelationships between the virtual world and the physical world. In the previous framework, digital twin frameworks, most of the framework, they are focusing on how to communicate with the digital twin execution models and the real physical system. But our systems engineering ontology, actually, we can represent the interrelations from a static way, from a formal way. So I think this is main, the main purpose for the systems engineering ontology to support digital twins.
Okay, thank you. And we have another question for a different topic from Grigoris Menzas. Hi, Grigori, welcome. It's how you see, or we see, the integration of ontologies with data-driven artificial intelligence approaches, for example, machine learning, in the manufacturing domain. Yeah, you see also here because we have a lot of data. So in maintenance, we have a big data. In supply chain, we have the big data, and there is a community which is called now AI. So there are other communities that try to extend this term and call it explainable AI. So maybe ontologists can contribute to this explainable AI. But the question is how, let's say, we can combine, let's say, machine learning techniques to ontologists. Yes, Melinda.
Okay, so this is exactly what I tried to show in my presentation. We start with text. We use deep learning to process the text to get the knowledge graph. From the knowledge graph, we infer whether we have an end-of-life event or not, and the failure mode associated with that event. That end-of-life event inference becomes the response variable for the machine learning to train the machine learning models. So this is not a future thing. This is what we are doing.
Farad?
Yeah, in fact, Barry Smith has a paper titled "Make AI Meaningful Again." So I recommend you to read that paper. And it's all about how to integrate ontologies and semantic with AI. Yeah, I mean, they kind of work together very closely, these two topics, because if we can give meaning to data, then we can do more intelligent machine learning. We can do better job as opposed to just meaningless data or numbers. For example, in our supply chain traceability use case, we are collecting data from different suppliers, and they obviously use their own schema and data model. But if we can integrate those data sets, then we have a larger data set to work with, and then we can apply machine learning to a much larger data set, which is harmonized. And the result of the models that we get as the output are more dependable because they are based on a larger set of data that is merged based on an ontology. So yes, it will obviously support if you use semantics and apply semantic models on data and machine learning.
So if I'm allowed to make a comment also, in my knowledge, some current machine learning techniques and algorithms are working on raw data, and they try to learn from patterns in raw data and learn or create knowledge from raw data. In some domains, they are successful. In the engineering domain, in manufacturing, and more generally in the engineering domain, I think we have to go beyond the raw numbers, go to the meaning of data. And what we have with ontologies, if we, let's say, use an ontology to create a knowledge graph. In this knowledge graph, we have the instances, so the individuals, together with the relations. And I know that there are some communities. I know one, for example, in the Technical University of Vienna, where they try to apply or to extend machine learning techniques to work on knowledge graphs. I mean, data that are linked with relationships, big data linked together, and develop machine learning techniques on this kind of semantically structured data. So I understand this is work in progress, but I think it is in line or along the lines of the paper of Barry Smith that Farad mentioned, make AI meaningful. And I personally expect that there will be progress in that direction. We have also one question from Hedy. which says that, I will read it. We can have agreement on terms used in the domain ontology, but what about agreement on the interpretation of those terms and relationships between them? Conceptualization. This is defined as conceptualization. Do you believe that in pluralism within the industrial domains? I think pluralism, that we are allowed to have different interpretation of those terms.
Very dangerous for an engineering. So, do we really, in engineering school and in businesses and in the Air Force, or in critical or in space, do you think people will go, oh, it doesn't matter, you can call a centimeter an inch? No, we don't do that. In engineering, I don't think it's like being in the arts. I don't think it's like theatre predictions. In engineering, we need to agree within the context of the terms we are using them, what their meanings are. And I think if you work for a company, we already have corporate type languages. We're quite firm on that. So I think if across domains, you might have different interpretations. If I go to aerospace, there will be a different culture and language there, but I think immediately you start to accept that you can have many different ways of describing things in an engineering concept around equipment, I think you're just asking for trouble, and the risks are horrible.
Yeah, I agree with Melinda, especially if you expand the domain of the ontology, the scope of the ontology, and it includes different organizations, different stakeholders. If you don't have a unified definition of a term in a reference ontology, it would be very difficult to use the same reference ontology for multiple use cases. But suppose that you are within a company and you just want to develop an ontology for your own application. Yeah, that's okay to have your own interpretation, and it does not agree with other organizations. But as a reference ontology, then you really need to have a really clear agreement on what you mean on each term, formally and informally.
Can I just mention, Dimitris and Farhad,
yes.
That's why we have standards. You know what the very first page of a standard is? It's a definition of terms. Everything you read in this standard in engineering has this definition. So this is the world we live in. We live in a world of standards. We live in a world of clear definitions. We don't live in a world of, I just want to be somebody else today, and that's okay.
Good. So I see a comment from Farhad here with regard to system engineering ontology. Farhad says that supply chain is an engineered system, and as such, so it needs to be connected with other elements, and the system engineering ontology is necessary, critical and necessary. So Jinjay, so I remember that we discussed in the group a lot about engineered systems and other systems, for example, natural system. So can you tell us a little bit about the engineered system and what is the focus of the system engineering ontology? Is it really on the engineered system or more generally in systems?
Yeah, I think currently in our systems engineering working group, the system we mentioned is much more focusing on the engineered system. I mean, some man-made system. So, but still, the systems engineering ontology we are still developed. I mean, the ontology is still under development. So that means we need more discussion to find more way to extend our current ontology. So, what I can say is it is very challenging thing to use the systems engineering ontology with some other domain-specific ontology currently.
And how if we take if you allow me to go a little bit further, so if we take the supply chain, so which is an engineered system, but as such, a supply chain is using elements of natural systems. For example, the environment. If you take a ship that transports containers in a supply chain or a truck, So this is using the sea, which is part of the natural system, or the truck using the atmosphere or something, which is part of the natural system.
Yeah.
So it is necessary or required to have these links between engineered system and natural system.
Yeah, I think yeah, of course, I think this is very important because from the systems engineering approach, actually, when you define the system, that means you need to define the system boundary and its environment. And because of the environment, then you will have some input to this system. I take one example is the sea. I mean the short water and the water actually they are totally different. I mean the sea and the lake they are different to the ship. On the perspective of the harm to the surface of the ship. So that's why I think the natural system and the engineer system is very important to identify the interreactions between them.
Very good. And also, I see that in the chat, so there is also some comments about symbols, because so we discussed it here about terms, but in the engineering domain, we're using also symbols. For example, in drawings, we have symbols, or also we have some other elements, for example, sounds or smells that I see here also. So how we can, let's say, include this kind of, let's say, entities or physical matters in ontologies, transform them to text definitions. Yeah, Melinda?
Yeah, so I mean, I think of these as just being attribute values and attribute.
I saw that I read that you define them as artifacts, so they can be defined.
Yeah, so but they're attributes. A motor makes a sound, and it's an indication of a problem. But the sound is measured with a meter, and the measurement itself is a value, and it has a unit. So all of these things are standard classes in ontologies. So I don't see that. And the PNID symbol one to me is a PNID is a tag. It goes back to what there's a coding system that describes what sort of equipment it is. It's in a CAD drawing. It's actually text. It looks like a symbol to us, but behind it, it's a tag. It's got a text. It's got a number. It's interpretable.
I think I agree with you.
Yeah.
Drawings have a lot of symbols, which is a kind of language. For example, in drawings, you have a lot of symbols about tolerances, and tolerances are clearly defined in, let's say, in the documents, etc. So it's a kind of language that can be also defined, I think, etc. Very good. And then in terms of standards, we talked about standards. So one of the contributions of Autocommons project and also the Industrial Ontology Foundry is to contribute to good definition of standards. And I know, and I think you know also, that there are standardization organizations and communities that they try to somehow transform their standards somehow in ontologies, or use ontologies to describe their standards. Or even there are corporations that what they do, they have a number of standards that they are using, and they have teams that they transform these standards to ontologies in order to implement them in applications, in their operations, etc. So my question is, what do you think? What is the role of ontologies, and particularly communities such as Autocommons or IOF, to the next generation of standards? So yesterday I heard the term smart standards. So will ontologies be useful to make standards more applicable, more useful, better, let's say, contribute to the interoperability among people finally?
I'm happy to have a go at that. Demetrius, has long been something that ever since I got involved with ontologies, because I have quite a long history with the standards community, because I was on the ISO 55001 committee, and it's immensely frustrating to me that ISO itself has vastly different definitions for its terms across its standards. In maintenance, it's chronic. There aren't two standards that define maintenance the same way. And then if you add in IEC and IEEE and ANSI, it would be great actually for the ontology community, the engineering community, to get together and to agree to align just their terms and definitions. And I think ontologies could find where the problems were, the most egregious problems, where things were most semantically different, and could then encourage the higher level JTCG type groups to actually align those. And ontologies would be a great way. But you'd need them on board because you need to import all their documentation, process it, and then work out where the major disconnects were between the terms and definitions used in the standards, and have one set.
Yeah. And what can I add is that there are two different artifacts, like ontologies cannot replace the standards. We still need the standards because in a way they need their own context. So, right. So what we can use standards to inform ontologies, to provide us with definitions. And also we can use ontologies to annotate the standards. Maybe in future, we don't want to have PDF files for standards. If we go with model-based systems engineering, maybe standards are represented in more machine readable fashion. And then we can use ontologies to annotate the standard text, for example. But my point is that there are two different things that they can support each other.
Jinji, you want to say something?
Yes, and I think currently from the systems engineering domain, for example, SysML, in maybe 20 years ago, they hope to create some graphical specification in order to realize the unified description for all the engineer systems information. And now they already changed this graphical specification back to the semantics way, I mean SysML 2.0, such thing. So I think maybe in the future, if we can, based on the ontology, we can develop some open source software which can be used to represent the ontology model. I mean the ontology model or ontology specific based on some ontology specification that will be used for the future. For the this is will be very helpful to make the ontology used in the real industry. I take some example. For example, if we provide different domain ontology specification and different domain ontology model library, and then we have some open source software which some other people they can use this software to manage their own knowledge, to create their own knowledge model. So I think this will be much helpful.
And also from my experience in IOF so far, so I observed that when we try, let's say, start with Autology, we are a group of people, so Autology is subject matter experts, and we try to define or to write down definitions of terms. So we try to see if there is a definition of a given term in some standards. And in, for example, in system engineering working group, so for one term, we find 5 or 3 or 4 definitions for each term. So maybe the work also, the process of developing ontologies in the industrial domain may help to align standards in this same domain. And then there will be another process of how standardization organization can work with that. But I think let's go step by step. So I think we are approaching the end of this session, but I think if we, I would like to clarify this point of that Eve raised. So, Eve, can you, if the managers can open the micro of Eve Keraron and explain, allow him to express his opinion? I can see if I can. I don't know how to open the micro.
Hi, Dimitris. Can you
Yes.
hear me? Yeah,
Yeah.
sir. No, I'm inviting Eve on stage. It's just my computer
very
was
good.
a bit slow.
Yeah. Sorry. Yeah. If you will be invited on stage and then
Yes.
and contribute. Yes, we hear you, Eve. Please.
Yes. First of all, thank you very much for the presentations and the exchanges we have. Actually, the point I mentioned was there is a lot of standards in industry already for to make interoperable physical plants and products. They are interoperable. The point is that intellectual information systems are not interoperable. And what I was highlighting is that there exist many standards, like standards on symbol for PAN ID or
Hi, Eve. In case we cannot hear you at the moment, so maybe you would need to authorize the microphone for the platform. There should be a pop-up, and you should click on authorize for the mic and video.
I think I don't see the authorize. But
I can hear Yves.
Yes,
I can hear you.
Okay.
Now, yes.
Okay.
Yeah.
Thank you. Somebody in the chat also mentioned S1000D. It's about to take data for every kind of civil and military aircraft, or S2000M, and there are many interesting standards with big efforts made on conversions on terms, concepts, properties, and so on. And I think we have not to start from zero. We have to start from all these standards also, and all the habits of industrials to share knowledge. PAN ID is a very efficient way to communicate, and with links with common understanding of symbols and things like that. And so I think we don't need to begin from scratch, but and also to valorize all the existing knowledge in industrial business standards.
Very good. Any comment to what you've said? I think I cannot agree more with that. So standards are let's say, long-term process, and in order for a community to arrive, a group of people to arrive to a standard, and this be published by ISO, for example, there is a long process of iterations, votings, etc. So there is a lot of value of it, and of course, it has to be valorized.
Yes.
And I think semantics and ontologies, all this process at least, may help this process to become more efficient, I hope.
Yes, the question is to digitize these standards, probably. And ontology can play a role, of course.
Exactly.
But maybe it's an enabler, but maybe not the only one. We need also methods to transform textual requirements in formal requirements and things like that. So,
yeah.
Okay, thank you.
Good. So we have 4 minutes. So I would like to invite, let's say, the speakers for 1 minute or so to say their final word before we close for lunch break. So Melinda?
A wrap up, Dimitris. You've caught me by surprise.
Yes, let's say a few seconds to say your final words. So.
Okay, so look, I maybe, given this is the IOF session, I think that it would be great if the speakers on the call, people who are listening, if they want more information about the IOF, we have a website, we have domain working groups. Most of us have private Git sites, we have active meetings. And I think that if you're interested in ontologies, this is a great way to both keep in touch with stuff that's starting to move quite fast, as well as hopefully contribute. So I'd encourage you to reach out to the IOF community and get involved, please.
Thank you, Melinda. Farad?
Yeah, I'd like to mention that it's a huge challenge. I mean, the domain is vast, right, in industry, and we really don't have answer to all questions. We just need to experiment and practice and fail. So, for example, one big question is a foundational approach the right approach? Well, we don't know yet. Maybe we just have, for example, one experience from biomedical industry. So, and it was successful. Will it experience the same level of success in industry? Maybe yes, maybe not. But let's give it a try. And as a community, let's just be open to that foundational approach, and we'll use IOF as a platform for that. If we fail, hopefully we learn something. But let's try and let's get something out.
Good. Jinji?
Okay, so I think systems engineering is some method which can be foundational method which can be used to define the ontology for different domain concept. But this is not the only way. But I think from our perspective, maybe this is one of the most interesting way we can try to use ontology to represent the domain-specific concept. So I think if someone who interested in this topic, maybe you can join in our working group meeting to discuss with ontology with using systems engineering approach and use your own domain specific approach. Okay, thank you.
Thank you, Jinji. And with that, I would like to thank all speakers, Melida, Farad, Jinji, for their contribution to this session, and also the Trust IT staff for the organizing and the taking care of all the technical aspects, running it well. So now I invite you, and I wish you to have a very good lunch break in your place. Unfortunately, we cannot offer you lunch this time, but we really hope that before the end of the Auto Commons, we have the opportunity to meet in person in the next global workshop, and then smell each other, Melida, and then feel well. Thank you. Goodbye. See you in the afternoon.
Goodbye. Thanks, everyone.
Bye bye.